This is a parallelogram ABCD where AB is parallel to CD and AD is parallel to BC. We have to prove that AB is equal to CD and AD is equal to BC. That is, the pair of opposite sides are equal to each other. And to prove this, let's draw this diagonal, that is BD, and let's quickly name the angles. This is angle 1, let this be 2, let this be 3, and let this be 4. Now we have two triangles here. If you look at this figure, we have two triangles, triangle ABD and triangle BCD. Okay, now if we look at this pair of parallel sides, that is AB and CD, so AB and CD, since these two are parallel lines, therefore this BD will be transversal, therefore this angle 1 will be equal to angle 2. How? Alternate interior angles are always equal to each other. So angle 1 is equal to angle 2. Now from triangle ABD and triangle BCD, isn't the side BD common to both the triangles? So side BD of triangle ABD is equal to side BD of triangle BCD, right? And just as we have discussed here, isn't AD and BC parallel? So from AD and BC, if these two lines are parallel, then this is transversal, therefore angle 3 is equal to angle 4, same alternate interior angles of the two parallel lines. So angle 4 of triangle ABD is equal to angle 3 of triangle BCD. Okay, now let me remove this. Now here, if you look at this, angle 1 is equal to angle 2, A, this side is common, S, and again we have two angles equal to each other, A. So from ASA criterion, we can say that these two triangles are congruent. Now we have established that these two triangles are congruent. Now you have to establish the correspondence of vertices and the correspondence of sides, that is, which all vertices are corresponding vertices and which all sides are corresponding sides. So if you look at this two triangles, and let's separate this, because this is the portion where most of the students make mistake. So if this is our triangle ABD, and if this is our triangle BCD, let me take a little bit higher. This is triangle BCD. It's a rough diagram. A, B, D, and B, C, D. So this angle 1 of triangle ABD is equal to this one. We have established that these two are congruent, right? So 1 and 2 are equal, and this 3 and 4 are equal, and this is the common side that is equal to each other. Now tell me, if I try to take this triangle BCD, imagine that you are holding this triangle in your hand and you want to superimpose this triangle on triangle ADB. So which all vertices will exactly fit over each other? So if I take this one, since this angle 3, that is, I can say this angle B of triangle CBD is equal to angle D of triangle ABD, right? So this vertex B will fit on this vertex D of ABT, right? So if I write here, let me take this a little down, X, V. So the vertex D of triangle ABT and vertex B of triangle BCD, these are corresponding vertices. In the same way, this angle 1 is equal to, since angle equal to 2, therefore the vertex D of triangle BCD will exactly fit over vertex B of triangle ABT, right? So B of triangle ABT and D of triangle BCD, these are corresponding vertices, and the leftover one is A and C. Therefore these A of triangle ABD and C of triangle BCD, these are corresponding vertices. From this one we can say that if you first take this one, that is DB, so the side DB is equal to side BD, right? This one, and therefore these are corresponding sides. The next pair of corresponding sides will be, these all are corresponding vertices. Okay, now if you now take this B and A, so side BA, the sequence is very important, will be equal to side DC, side DC of the triangle BCD, right? BA, that is this one, and this DC. Then this is also corresponding vertices, sides, and then you have to take this D and A and then B and C. So side DA of triangle ABD will be equal to side BC, side DA and side BC. So this is also pair of corresponding sides. So we now know the corresponding vertices, and now we know the corresponding sides. The concept is, if you have established that the true triangles are congruent, now you have to superimpose one of the triangles over the another one. So it means from this figure you can see that from corresponding sides, the AB, that is this one, if you look at this one, the side BA, that is this one, is equal to side CD, DC, that is this one, right? And next, if you look at this DA, that is the side this one, is equal to side BC, that is this one, right? So we can see that from the concept of congruent triangles, we have established the corresponding sides, and therefore we can say that the opposite sides are equal to each other.